Time travel. Just the thought of it sends shivers down the spine. The idea of journeying through time, of experiencing the past firsthand, or peering into the mysteries of the future, has captivated the human imagination for centuries. But the burning question remains: is time travel possible? Let's embark on a journey through science, history, and the realms of possibility to uncover the truth behind one of the most intriguing questions humanity has ever asked. Let's start with the basics. What exactly is time? Time is a dimension, much like the three dimensions of space we're familiar with: length, width, and height. Together, these dimensions form what physicists call space-time. According to Einstein's theory of relativity, time and space are intertwined in a single continuum, and the fabric of space-time can be warped by gravity. This warping of space-time is what we perceive as gravity. But here's where it gets interesting. If space can be bent, so can time. Einstein's theory of relativity opened the door to the possibility of time travel, at least theoretically. You see, the faster you travel through space, the slower you move through time relative to someone standing still. This phenomenon, known as time dilation, has been proven through experiments with atomic clocks on high-speed jets. The clocks on the jets ticked slightly slower than identical clocks on the ground, showing that time does indeed slow down at high speeds. But this is just a small piece of the puzzle. The concept of time travel takes a more dramatic turn when we delve into the idea of wormholes. A wormhole, in theory, is a tunnel connecting two different points in space-time. Imagine it as a shortcut through the fabric of the universe, where you could enter one end of the wormhole and emerge in a different time or place. Sounds like something straight out of science fiction, doesn't it? Well, it is. Wormholes were first predicted by Einstein and his colleague Nathan Rosen, but they remain purely theoretical. No one has ever observed a wormhole, let alone traveled through one. However, the idea of using wormholes for time travel has intrigued many scientists. If a wormhole could be stabilized, no small feat, considering they're predicted to collapse almost instantly, it might be possible to use it to travel to the past or the future. But even then, there are paradoxes to consider. One of the most famous is the grandfather paradox. If you traveled back in time and prevented your grandfather from meeting your grandmother, you would never have been born. But if you were never born, how could you have traveled back in time in the first place? These paradoxes raise deep questions about the nature of time and causality. Now let's take a step back from the theoretical and explore the historical perspective. Throughout history, time travel has been a common theme in mythology, folklore, and literature. In ancient Hindu texts, the Mahabharata describes King Raivataka Kudmi, who travels to the heavens to meet the creator god Brahma, only to find upon his return that many ages have passed on Earth. Similarly, in the Japanese tale of Urashima Taro, a fisherman visits an undersea palace and returns home to find that centuries have passed. These stories, while fantastical, reflect a deep-seated human fascination with the idea of moving through time. In more recent history, the concept of time travel has been explored in countless books, films, and television shows. From H.G. Wells' The Time Machine to the Back to the Future series, these stories have shaped our cultural understanding of time travel and fueled our imaginations. But while fiction has taken liberties with the idea, science has remained cautious. So has anyone ever succeeded in time travel? The short answer is no, at least not in the way we typically think of it. No one has stepped into a machine and emerged in a different era. However, as we mentioned earlier, time dilation does occur. Astronauts aboard the International Space Station are traveling at such high speeds that they experience time a tiny bit slower than we do on Earth. In a sense, they are time travelers, albeit only by a few milliseconds. Another intriguing phenomenon is the concept of closed time-like curves, which are paths in space-time that loop back on themselves. In theory, if you followed one of these paths, you could return to your starting point in time. Some solutions to Einstein's equations of general relativity suggest that closed time-like curves could exist in certain extreme conditions, such as near rotating black holes. But again, this remains purely theoretical. Theoretical physicist Kip Thorne, a colleague of Stephen Hawking and one of the leading minds in this field, has explored the possibility of using wormholes as time machines. However, even Thorne acknowledges the enormous challenges involved, from the vast amounts of energy required to the potential instability of the wormholes themselves. And then there's the problem of causality. If time travel were possible, the paradoxes and potential changes to history could have unpredictable and possibly catastrophic consequences. Stephen Hawking himself was skeptical of time travel. In fact, he once held a time traveler's party, sending out invitations after the event had already taken place. No one showed up, which he took as evidence that time travel to the past is unlikely. Hawking also proposed the chronology protection conjecture, which suggests that the laws of physics may prevent time travel on macroscopic scales, protecting the universe from paradoxes. But what about the future? Could we one day develop the technology to travel through time? Some scientists believe that it might be possible, though it would likely require advances in physics and engineering that we can't yet imagine. Others argue that the very nature of time might make such travel impossible. Time, after all, is not just a dimension. It's also a measure of change, of cause and effect. Traveling through time might require us to rethink our entire understanding of the universe. Yet the allure of time travel remains strong. It taps into something fundamental about the human experience: the desire to understand our place in the universe, to see where we've come from and where we're going. Whether or not time travel is possible, it forces us to confront deep questions about the nature of reality, the limits of science, and the mysteries of existence. In conclusion, while time travel captures our imaginations and provides endless fodder for science fiction, the scientific reality is much more complex and uncertain. Theoretical possibilities exist, but they are fraught with challenges and paradoxes that we have yet to overcome. As it stands, time travel remains in the realm of theory and imagination, but who knows what the future, or the past, might hold. So, as we ponder the possibilities and dream of journeys through time, let's remember that the real magic lies not in bending the laws of physics, but in exploring the mysteries of the universe and pushing the boundaries of our understanding. Whether or not we ever travel through time, the journey of discovery itself is a worthy adventure. Thanks for joining me on this exploration of one of humanity's greatest questions. If you're as fascinated by the mysteries of the universe as I am, make sure to like this video, subscribe to the channel, and hit the notification bell so you don't miss our next deep dive into the unknown. Until then, keep wondering, keep questioning, and keep exploring the wonders of time and space.